Now, everybody, don't forget to tell me, okay, about the recording. You still get bonus points, but I could still forget. All right, so welcome to Indigenous Peoples Day, also known as Columbus Day. It's not a holiday, official holiday here at Berkeley, but we do want to celebrate and recognize and appreciate the Indigenous people of that we have connected with in various ways, and acknowledge our past. We can't go into greater detail right now, but I think it's important to take a moment. What I'm going to do now is switch back to our notes, and I recently sent out a new set of notes where I just made a very small adjustment. So don't worry, if you have the old set, it's fine. This will be fine for the next lecture or two. But toward the end of this sequence on SQL, there's some better notes I found talking about inner and outer joins. So you can upload those when you get a chance. All right, so let's go back to where we left off. We were talking about SQL, the language, and we're using this little mini database to go through examples. And just to refresh your mind about it, we're going through, this is a customer that lists the name of the customer, the city the customer lives in, and the discount that the customer receives. The product is the product, and the city the product is made in this case, and the quantity we have in stock, and the price that we paid for the product. Agent also has the city the agent lives in, the commission the agent receives, and then when we have an order, we note the date, the customer, the product, the agent, how many of those products, and at what price. And note the price here may be, and almost always is, different than the price here, because this essentially is wholesale, and this is our retail price. Okay, any questions on the example we're going to use? Okay, and just raise your hand or unmute yourself if you'd like to ask a question anytime. All right, so I showed you last time the relational algebra to answer a query like this first one here, find all the customers with their customer IDs from San Francisco, and then we went through what that looks like in SQL. And just to refresh your memory there, you should have this: select CID, CNAME from customer where city equals San Francisco. Okay, and so in particular, I wanted you to note that the select, when we use this term select in SQL, it's not the same as the select here in algebra. So keep those two different. This is a sigma, and we call it select, but it's not the same. And here's another example where you can see that here we use the project operator, and that gives us the equivalent of that is to do this: select all cities from agent. And then the point of number 2 here was the distinction between all and distinct. So if you put in all, or in fact, this is the default, all is the default, that means you can leave out all, can omit all keyword, then you'll get just this, you'll get multiple duplicates of the city. And here, this removes duplicates. Okay, so we're all caught up. Any questions? All right, let's go on. So now let's find orders from New Orleans customers. So the way we do this is we're going to select now O.OID from customer as C, order as O, where C.CID equals O.cid and C.city equals New Orleans. Now, let's look carefully at what's going on there. A couple new things we're introducing. First of all, this I've treated probably something new about this is a rewrite of a name here. We use this as keyword to rename the customer table just because it's convenient that I can just use these little C dot and O dot rather than writing out order and customer there. Okay, so that you'll use very, very commonly, so get used to it. And then for customer is C and order is O, and so this is telling you order.oid. So that's going to select the OID from the order table. And then we're putting a condition on it that the customer ID has to match the order ID. Okay, and that in the customer table, the city of the customer, the city the customer lives in has to be New Orleans. Okay, so what is that going to do? It's going to give me the orders that match this, that have this customer, and that customer in turn comes from New Orleans. Okay, so what is that like in relational algebra? Anyone? How would you do that third query in algebra? Just put your hand up if you think you know. What would be the operator that you would use to find the orders from the New Orleans customers? Remember, the orders table doesn't have the name where the customer lives. Good, Jake. What would you say?
I think you could join customer on order by CID equal to CID, just a natural
right.
join.
That's right. Thank you, Jake.
And then you could select using city equals New Orleans.
Okay. And then we project order ID from that, right? Exactly right, Jake. Okay, so what's going on? Now here I was able to achieve a join command without using a join explicitly, but by basically constraining that these two tables have to line up, if you will, that there's a join condition that's right here. It's embedded in this statement right here, okay? And once you have the join, then you can also do the check that the city in the customer table is New Orleans. And it's very nice because notice we have a city in the agent table and in the product table. So here we can specify that we're talking about the city in the customer table. So it's not ambiguous. And this is a pretty big step here. By the way, I should have been careful about putting in my semicolon here. Okay, that's very important to end the SQL statement. And what's important to notice here is that we're essentially defining what we want. We want this conditions to be true of the output, but we're not saying exactly how it gets done. Okay, and this is again this point about this being declarative, SQL being declarative rather than procedural. And I also want you to note, some of you who are computer science or have taken classes might be worried that this gets used before it's defined, right? We define it down here, what O is going to mean, but that's also not a problem because what SQL does is it essentially interprets the whole query. When it hits the semicolon, it reads everything in and figures everything out, and then it processes it and generates the output, okay? So you're just laying out a very careful specification in the body of this SQL query, and then the software will deliver it to you, okay? Any questions about how that gets achieved? We've just done a join by putting in a special condition in the where clause. Okay, good. So now let's go into all possible combinations of agents and customers. And we know what that would be. What would be the, I won't write it out, but what's the operator that you would use if you wanted all possible combinations in algebra? Come on, you guys, you remember that. All combinations of two relations, what do we use there?
Cross product.
Cross
product.
Good, okay, great. Cross product, right? In algebra, in relational algebra. Okay, but here we're going to do it very differently. We're going to say select star from agent customer. All right, now this is the first case. Remember I said that the star in SQL it gets overloaded. It gets used for different purposes. And this is the first purpose you'll see it. So this is where it's basically a wild card, and it's saying, give me all the attributes in the combined tables. So star means give me everything. And what I'm saying here is by not having a where clause, there's no condition, right? So it's just saying, give me all combinations of agents and customers, right? So it's essentially doing a cross product because of the lack of a condition. Right? Because there's no limit on it. It's going to then pull out everything from these two tables, right? Join them up, put all those combinations together, and spit out a combined big table with all the agent information, all the customer information, and then for every possible match that could possibly be out there, right? Of agent and customer. Okay. So that's the point here is that there's no where clause, no condition. So it gives you everything. Okay. Now let's go on to the next one, the arithmetic calculations. Now,
Professor?
let's say, yes?
I actually had a question on number 4. Is that different, this query, so like all from agent customer, is that different from an outer join, or are they synonymous essentially?
Yeah, this is actually very similar to an outer join, yes. And if you're familiar with outer joins, we are going to get to this at the very end. The reason I'm glad you brought it up. I'll just say that the explicit joins, you can say inner join, left join, right join, outer join. You can use those keywords, but it turns out that you can do these without those keywords. And there is an issue that not every keyword is part of the SQL standard. So what I'm trying to do is I want to focus on the real core operators for SQL. However, I know that many of you, if you used it in industry, you might have gotten comfortable using those other keywords like join, and so that's why that's covered at the end of the notes. Okay, and we'll touch on that.
Okay, thanks.
But yeah, this is an inner join. Are we supposed to put semicolon at the end of every line? No, Malik, it's only at the end of the entire statement, because that basically tells you I'm done, and then the system, the code will read that all in and do something with it, but it waits for you. You can do multiple lines until you hit the semicolon. Okay.
Gotcha, thank you.
Okay, good. And all right, great. So I like where you're answering each other's questions, and if I don't happen to look over at the chat, just don't be afraid to jump in and ask me.